This is an introduction to implicit differentiation. Implicit differentiation is differentiating an equation with two variables, usually x and y. It requires the mastery of all of the rules when differentiating, like the chain rule, product rule, and quotient rule. So usually you'll be asked to find dy over dx, which is found by differentiating both sides of the equation. And the question is, by what variable should we differentiate, x or y? And the answer is usually we use the x variable. So we multiply both sides by d over dx, signifying that we're going to differentiate. And if we do it to the left side, we also need to do it to the right side. So equals d over dx 25. Now, dealing with the left side first, differentiating this, we get 2x times dx over dx, which is 1, so we don't need to write that. So then we add it by y squared, which is 2y dy dx, because we need to do the chain rule here. When we differentiate y squared, we get 2y times dy over dx. And then differentiating 25, which is a constant, gives us 0. Now all we need to do to find dy over dx is isolate the terms. So we get 2y over 2y dy dx equals negative 2x. And dy over dx equals negative 2x divided by 2y. And that is your dy over dx. You can simplify and make this negative x over y. So basically all we're doing is finding dy over dx by differentiating with respect to x. In this case, same concept, we differentiate both sides, d over dx times xy plus y squared equals d over dx times 6. Now differentiating here, we notice that this requires a product rule because it's x times y. So we can do x times the derivative of y, which is x times dy dx, because the derivative of y with respect to x is dy dx, plus, because we're doing the product rule, plus y times the derivative of x, which is 1. So y times 1 is y. And y squared, when differentiating with respect to x, is 2y. We did this above, 2y dy dx using the chain rule. And the derivative of a constant, 6, is 0. Now, this is the easier part. We just need to separate the terms. So what I'm going to do is x dy dx plus 2y dy dx is equal to negative y. And then we can factor out a dy over dx. And we get x plus 2y equals negative y. And all we need to do now is divide by x plus 2y on both sides. So dy over dx is equal to negative y over x plus 2y. And that is our answer for this question. Next question, find dy dx if the given equation is e to the power of xy equals x plus y. Now, similar to the previous questions, all we need to do is differentiate by d over dx with respect to x. So first part, multiply d over dx by on both sides. So we have d over dx times e to the power of xy equals d over dx times x plus y. Now we'll work with the left side first. When you differentiate e to the power of anything, you get e to the power of anything times that power. So e to the power of xy times, I'll put this in brackets, xy, differentiating xy with respect to x gives us, we need to use the product rule, so that gives us x times the derivative of y is dy over dx plus y times the derivative of x is 1, so y times 1 is 1. The derivative of x is 1 because you're differentiating with respect to x, so that would give us dx over dx, and that is 1. Now, with the right side, it's pretty simple. Derivative of x, like I said, is 1, and the derivative of y is dy over dx. And now, before isolating dy over dx, it's important that you expand the equation. So in this case, that would mean multiplying these terms, both of these terms, by e to the power of xy. So what I will do now is multiply through e to the power of xy times x times dy over dx plus e to the power of xy times y, which is simply y times e to the power of xy. And that is equal to 1 plus dy over dx. Now we can isolate dy over dx. So what I will do now is subtract both sides by dy over dx. So we can write this as x e to the power of xy. There is a multiplication sign between these two. I'm not writing it because it's self-explanatory. And so we get this. I will subtract dy plus dy over dx, and I'll add y times e to the power of x times y. So what I get now is this minus dy over dx is equal to 1. I'll have to subtract y times e to the power of xy. So 1 minus y to the, times e to the power of xy. Now I can factor out dy over dx. So factoring dy over dx out, I get x e to the power of xy minus 1. Right? Factoring dy over dx out gives us 1. And that is equal to 1 minus y e to the power of xy. Now all we need to do is divide both sides by x e to the power of xy minus 1. And that will give us dy over dx. 1 minus y e to the power of xy over x e to the power of xy minus 1. And that is our answer for this question. All we had to do is differentiate both sides by x, and then factor, or expand in this case, and then isolate dy over dx. So similar question with a trigonometric equation instead. D over dx times sine xy equals d over dx x squared minus y squared. So now all we need to do is differentiate, and in this case sine of xy is equal to cosine of xy times, because chain rule, times, and then if you use chain rule with xy, we also need to use the product rule. So xy is x times dy dx plus, I'll put this in brackets, plus y times 1, which is y. And then dealing with the right side, we get 2x times dx over dx, which is 1, and y squared, which is 2y times dy over dx. Now, like before we isolate dy over dx, it's important to expand. So we can write x cosine xy dy over dx. So that is multiplying by this term, this term, and then we multiply by y. So we get plus y cosine xy. And the right side remains the same. So now what we can do is we can manipulate the equation by putting dy over dx all on one side. So we can write x cosine xy dy over dx, and we can add 2y times dy over dx on both sides. So we get plus 2y dy over dx, and we can subtract y cosine xy from both sides at the same time. So that gives us 2x minus y cosine xy. And now we can isolate dy over dx by first factoring dy over dx here. So we get dy over dx and x cosine xy plus 2y, and on this side it remains the same, minus y cosine xy. And now we can finally isolate dy over dx by dividing both sides by x cosine xy plus 2y. So that gives us this equation. And that is our answer for this question. So, really similar question. Find dy over dx given the equation x cubed plus y cubed equals 6xy. Differentiating both sides with respect to x gives us this. And now differentiating left side first, we can do 3x squared, okay, plus 3y squared dy dx. And that's our left side. Right side will be product rule. We can club 6x and y. So these are our two separate terms. When we do product rule, we can do 6x times derivative of y, which is dy over dx, plus y times the derivative of x, which in this case is not 1, it is 6. So that will give us 6y. So now what we can do is, there's nothing to expand per se, so we can manipulate the equation to put dy over dx on one side. So we get 3y squared dy over dx. Subtract both sides by 6x dy over dx. So we get this equals 6y, and we subtract both sides by 3x squared. 6y minus 3x squared. And so now we can factor out dy over dx. 3y squared minus 6x equals 6y minus 3x squared. Dy over dx is equal to 6y minus 3x squared over, dividing both sides by 3y squared minus 6x, gives us this equation as our answer. So implicit differentiation is easy once you understand the steps. The first step is differentiating, usually by the variable x. Second step is, actually this is differentiating both sides separately, and the second step is expanding if anything is there to expand. And the third and final step is to factor dy over dx. And that is how you use implicit differentiation to find dy over dx.